Hello, fellow viewers. My name is Asta Saidak, and this is for the final project of the spring semester of CS341. Today I will be talking about the Prolog programming language. It is quite unique, and it has very interesting features. So let's begin. Prolog is the first logic programming language created by Alain Colmer in France in 1972. As you can see, it stands for the French translation for programming and logic. The pro comes from here and the log comes from here. The applications of this language include proving theorems. It's used in many instances of artificial intelligence. It was first actually used for natural language processing, and interestingly enough, it is part of the code for IBM's Watson supercomputer. So Prolog is a declarative programming language where logic is expressed in terms of facts and rules, meaning that we focus on what to do and not how to do it, and making it easy to read and verify the correctness of your code. The way to use Prolog is to write a program that declares some rules for the computation and then send a query asking a question on these rules. So before I begin the demo, I'd like to talk about some logic programming ideas. It's comprised of two things, facts and clauses. Clauses are basically rules, and as you can see, it looks something like this, where the H is the head, or the conclusion, and B1 through Bn is the body condition. So if B1 through Bn, then H, or it's read as H if B1 and B2 and through Bn. Then we also have facts, which are basically just rules with no body, and they just stand alone and can be used inside of rules. So let's begin. The IDE I'll be using is both an editor and a compiler for Prolog. It is at swish.sui/prolog.org. And the first example I'll be doing is converting Fahrenheit to Celsius. So let's say we have a function called convert, and we pass it the Fahrenheit temperature and we pass the return variable, which is the Celsius temperature, and let's call this convert. And then let's say we declare that ctemp is this computation. And when we run this and pass it the temperature of 66, we should get, well, 18.8 repeating as the Celsius temperature. So we can expand on this example by, let's say, defining some facts. And these facts could be, let's say, a city has, let's say it's Chicago, it has an average temperature of 45. And then let's say we have another city and its average temperature is 76. And let's say we have a third city and its average temperature is this. Then we can define a rule in which we take the name and we compute the average from the program. So we can say that this city, named whatever, has a temperature F temp. And then this is how we extract the Fahrenheit temperature, and we return the conversion. So let's say we send the query on Chicago. Let's see what happens. I believe this has to be uppercase. Let's try again. Oh, one important thing. So a rule is defined as, this is the head, and it has if it has multiple clauses or body conditions, they have to be separated by a comma if we mean and. So this comma means we grab the city, and if it's true and we find it, then we find the Celsius temperature. So when we run this again, we get 7.2. Easy enough. So now that we're done with that, that was a fairly simple example. We can go on and find different computations on sets of animals, perhaps, and let's see how that works. So let's say I've declared a set of animals that have the attributes defined as their name, the kind of mouth that they have, the kind of outsides that they have, and the kind of arms that they have. So let's say we have a lion that has fangs, it has fur, and it has claws. We can run a query that asks for all the animals that have these attributes. So we can say that we don't care about the kind of animal, so we denote it as an underslash. And then let's say we want to find all the animals that have fangs, and then we don't care about the rest of the details. So we can send it this query, and it will pass us back, hopefully. Oh, that's right. We have to pass it the name as a capital word. And so this means that it will return this variable of all the elements that are true. So we get the lion as the first one, the seal is the second one, and the dog is the third one. And we can verify that this is true right here. We can do other things. We can also say, if you can basically return a list of things, and that's a fairly simple example. Another example that we can do is an interesting if-else clause, kind of. We can determine if a student will fail. So let's look at this example. Let's say that we can delete all this. So let's say that we have a function or a fact. This makes a person a student. Let's say if her name is Lisa. And then we have a student named Mark. Now let's say that Mark partied pretty hard this weekend, right? And so let's say that because he partied, he did not study. And let's define this clause to be the no study clause, and it means that if the person partied, they didn't study. So then we can define another clause saying that if the person will fail, if the person is a student and they did not study. So let's see how this works. We can ask the query, will Mark fail? And that should return true, because he partied. And that means he did not study, which means that the clause will fail takes the condition not study. Let's see if Lisa will fail. And she will not. So, in the end, this concludes my demo of Prolog. Of course, these were fairly simple examples of what the kinds of things that Prolog can use, but if you think about how simple it was to figure out the logic in that, it becomes a very interesting subject to learn. And you can also see how very useful it becomes in things such as artificial intelligence and verification of proofs. Thank you for tuning in. This has been Asta. Goodbye.